Here we have an interesting prototype development of the OTR splitter, this time being used on massive extra wide OTR tyres, which are filled with polyurethane foam and have a bonded steel rim still in place. This requires a different approach to cutting, where a lot more attention is paid towards ensuring the outer diameter of the tyre rolls smoothly, which is why this machine now features distinctive rollers at the front. These foam-filled tyres are particularly difficult to recycle and have been something customers of the regular OTR splitter wanted a solution for. This prototype machine, now in the testing phase, can deal with these tyres even with the rim in place. The tyre requires more revolutions of the cutting blade to cut through the tread section. As there is no idler wheel to counteract the force of the blade, it requires more cutting time, hence the tyre rotates more times to get through the tough tread section, which is reinforced with steel wire throughout. Having said that the machine still cuts through it with ease, the still image coming up shows the thick cut through the tread section, which has exposed the steel wires within. The tyre is then removed from the machine, rotated around and placed back into it so that the other side of the tread can be cut in the same way. The cutting operation is simple. The operator begins the cutting blade, which has sprockets on either side to send rotational drive into the tyre. The tyre is then hydraulically lifted slowly up into the blade so that the blade exerts more pressure on the tread section. This is done in stages, with the blade cutting the full circumference of the tyre before the tyre is gradually lifted up some more. While a slightly slower process than tyres that have no rims, it is still done in a sufficiently timely manner given that so few other options exist for dealing with these mammoth tyres. The tread section must be cut horizontally. In this instance, a cutting blade is used, which is unfortunately an unavoidable step in the process. There will be aims to develop some method for doing this more efficiently with future R&D work. This slices the tread section so that a pry bar can be slid in to peel off the central tread section. Once detached sufficiently, the forks on a forklift truck provide more force to further peel off this section. The machine can then be used to rotate the tyre, which essentially machines off the tread section. The tread section is now removed from the tyre and can be moved elsewhere. It can be cut using the OTR shear, which will make it easier to bring to a shredding facility. Here is what remains of the tyre in the machine. The thick polyurethane core is still inside. A pair of forklifts is used here to extract the polyurethane core, which once it starts to become detached, quickly loses its grip and falls away from the tyre. Here is the polyurethane core sitting on the ground, fully detached from the tyre. This is a relatively soft material, which is now very easy to shred or cut using a shear. Now that the tyre has been cut this way, the rim can be removed with relative ease. This separates three different materials, which are the rubber tread section, the polyurethane core, and the steel rim, each of which have their own distinctive recycling avenues, but something which is now possible with this OTR splitter. To discuss your tyre recycling needs in more detail, visit Gradeall.com.